Okay, so we've made it through the 6 videos talking about the prep work for algebra. So this is the start of our Engage New York work for algebra. So it says Lesson 1, Graphs of Piecewise Linear Functions. I'm going to try to make this as easy for you as possible because it wants you to watch a video. Rather than making you find the video, I'm going to pull up the video. So the goal of this is to watch this man who's walking around. We are going to try to graph his elevation versus the time that it's happening. Elevation means the up and down. So where does he start? How fast and how far is he going? This is going to be a brand new concept for you. So if you're confused at first, I will help you. So just watch the video, and then what I want you to do is really, in that exploratory challenge, is write down what you think is happening. So again, elevation versus time. And they're going to show a graph. So we're watching this gentleman who's starting up high. You can see him up in the top right. Okay, so we want to graph the story. Right now, all I want you to do is really just write down what you think is happening. We're going to watch it in half speed so you can really see what's happening at the times. We're going to do the half speed one more time. One more time, Mr. H. Come on back. There we go. So you're watching the clock in the corner. You're also watching to see what this gentleman's doing. Oh, now he's going down. Is he going down? Well, no. Oh, he's going down. Is he going down? Oh, he's going down. Is he going down right now? Is he walking flat? I mean, he's hopping, skipping kind of, but that's not quite what we're looking for. And no, I don't want the answer. I don't want the answer. Psh. Okay, so what do we think was happening? And again, this is truly based off of what you saw on the time versus what the guy was doing. Now, I don't have the video up there, so hopefully you wrote down something like this. And I'm guessing at this point. So from 0 to 3 seconds, what was he doing? Well, he was walking flat. So he was staying at the same height. Well, here's my next question. Was that same height ground level? Was it up? Was it down? Where was it? Well, this was at the top. So this was at the top of the stairs. And I'm going to grab my book here because I want to make sure that I'm talking you through this correctly. So then for the next couple seconds, and I think it was just seconds 4 and 5, but I'm not 100% sure, so I'm going to review my own work. Let's see. Was it seconds 4 and 5? Oh, come on, come on, come on. Oh, it doesn't even have in my book what seconds it was. I think it was seconds 4 and 5, we'll call it. He hit that landing. So once he hit that landing, he was at the same, 4 and 5, he was not at the same, or at the landing. He was going downstairs. So he's going down the stairs. So there's a level change. So he was staying, then he went down. Then he hit the next landing at 6 and 7. And a landing is where he was turning to go down the next set of stairs. So let's start up here. He's walking to the stairs, he's going down, and then he hits that landing, which he stays still on. So that's staying flat again. Then he's going down the stairs, let's call it 8, 9. And then he's on the ground from 10 to 14. Okay, so we've got something like this. This is us walking through it. How can we make a graph of what was happening? Well, down here, we're going to have time in seconds. We're going to call this the elevation, which is the height, and we'll do it in feet. Now, do we know actually how high he was? No. So let's guess. So we're going to call it 2 feet, 4 feet, 6, 8, 10, 12. So let's say he started off at 12 feet. That's about a story and a half. So then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. Okay, so he started off at the top. So this is where he was starting. For the first 3 seconds, from 0 seconds to 1 second to 2 seconds to 3 seconds, he stayed flat. Why? Because he was walking at the same elevation for the first 3 seconds. Then he went down some stairs pretty quickly. He went about halfway down. So over the course of 5 and 6, he dropped down to that 6 foot mark. Okay? So there's the change in elevation. Why? Because he was walking down the stairs. Oh, not 6, Mr. H. Sorry, hold on. 4 and 5. So he was walking down the stairs pretty quickly. Then he hits that landing. So from 5 to 7, he stayed at that 6 foot. Then for 8 and 9, he dropped down to the ground level. Okay, so now we're here. So he stayed flat. He dropped down the stairs. He stayed flat on the landing. He dropped down the stairs. And then he stays on the landing the rest of the way. Okay? So we are able to walk and talk our way through it. Even if we never saw the video, we can say, hey, this person stayed at the same level for 3 seconds, went down for the next 2, 3 seconds of, or 2 seconds of flat, down the next 2, 5 seconds flat. Okay? That's what we're really doing in this lesson. So let's move on. Let's let you try to do something here. So here's example 1. And just so you know, I'm like jumping around things. So the room is almost ready. It's Friday before you guys come back to school. I've got a bunch of papers in the back corner. I'm charging up your Chromebooks. I'm charging up the algebra calculators, which are amazing. Like I'm coming together a little bit, but as you can see, like I'm a little flustered. My hair's all over the place. I haven't shaved for a couple days. Like my neck's red because I'm stressed out. Why am I stressed? Because I want to make this year the best year that you guys have had, even though it's a little different. So I don't know why I went there, but anyway, we're getting close. So if you see me jumping over things, it's because I'm walking around your calculators, your Chromebooks, all of that. Okay. So this is to each their own. It says, here's an elevation versus time graph of a person's motion. Can we describe what the person might have been doing? Now there's 3 things that I really want you to take notice of, actually 4 things, before we even start. On this graph, there are 4 things that are already written down. The title, what's on the x-axis, what's on the y-axis, and then it is labeled. Okay, so when you have a graph that you're making, you better have a title. You need to label both axes, and then you need to have the rates of which we're looking at. Okay, so what might be happening with this person? Well, after we just talked about stairs, we could say, okay, well, the person's at the ground level. He's walking up the stairs for about the first 3 seconds. He takes a break. He runs up the stairs. Oh my gosh, he takes a break, he takes a break, he takes a break, he takes a break. Then he jumps, because he's like a parkour guy, I don't know. He jumps, so he went down all of those feet really quick. He hurt himself. Okay, I'm good, and then he like rolls to the ground. That's one way of thinking it. I personally love to use an elevator. So at 0 seconds, I'm on the elevator, and the elevator is going up to the 10th floor. Boop. And then we're waiting for people to get on. Then the elevator's going up. We're waiting for people to get off and then get on. The elevator goes down to the first floor, up. Let people off. Elevator goes down. You don't quite know where the video stops because we're using this new device and Yep, love it already. So you can use pretty much any type of idea that you want that describes height and time. Stairs, elevator. Would a ball work? Not so much, but it could be a balloon. A balloon went up, got caught in a tree for a couple seconds. Up, the wind blew. It kept going up, got caught in a tree. Oh no, and it popped, and it dropped, and it got caught by me, and then I went, ah, and then I threw it to the ground. Okay, so even though it says, what could the person have been doing? It could also be an object or something like that. And my camera's all tilted funky now. Oh man. Okay. So really, this was the first lesson. Here's what you need to know. A piecewise defined linear function has non-overlapping. That's the key here. So linear, straight line, straight line. It does not overlap. So it stops like this. Okay? This is a piecewise function. It stops. This is an open circle, which means it's not the same point. It goes down, open circle, and then it keeps on going. Piecewise. Linear, but it's not going to be a fully linear function, which is just one straight line. It has multiple straight lines that do not overlap. So this was our first lesson, really just trying to get into the habit of describing a graph verbally and then possibly graphing it on our own. Okay? Yay.